Hello, protocols, packets, and programs. This past Saturday was Free RPG Day, which celebrates gaming, dice, and the ability to coordinate a schedule with more than one person. I've mentioned before how role-playing games are an excellent way to build threat modeling skills. Present players with a door in a dungeon and sit back as the analysis unfolds for several hours. RPGs are also an excellent tool for building analog fuzzing skills. Find an ambiguous rule and watch as players attempt to bend it to their will. Such discussions have inspired phrases like rules as written, rules as intended, and rules as fun to describe these different methods of interpretation. AppSec also looks at code as written and code as intended. It just never spends enough time on the fun. Which means this week we talk with Artur Cygan about building fuzzers, refining how they work, and why they've been such a successful AppSec tool. Grab some dice and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. Think your terminal emulation is secure? Think again. Passwords and firewalls alone won't protect you. Cyber threats are evolving, and so should your security. Rocket Secure Host Access gives you phishing-resistant, password-free protection with leading-edge encryption. Your mission-critical systems deserve more than good enough. Secure your green screen access and stay ahead of the threat. Rocket Secure Host Access. The future of TE is now. Learn more at securityweekly.com/rocketsoftware. This is episode 336, recorded June 23rd, 2025. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Hey, almost ended June. I don't know where time goes, but I'm here for the vibe fuzzing.
Vibe fuzzing. Let's see how many different ways we can just add vibe to the thing. Vibe D&D. That would be something else. But here to talk about fuzzing is Artur Cygan. He's a principal security engineer at Trail of Bits, where he audits client software for security flaws. He's been programming for over 20 years and is passionate about making computer systems secure. His interests cover binary exploitation, fuzzing, which is convenient for today, and functional programming. Hello, Artur. Thank you for joining us.
Hello. Thank you for inviting me.
So fuzzing, listeners in the past have, I think, heard me, extol the virtues of fuzzing. I'm definitely a fuzzing fanboy. And it's been a successful tool for just randomly throwing garbage, if you will, at applications and seeing what happens. But throwing garbage at applications perhaps could also describe vibe coding. So we maybe need to refine our definitions here. Give us a little bit of a setup, an intro to how do you define fuzzing? What to you does fuzzing mean?
Well, I think fuzzing has a reputation for a good reason. It's been one of the most successful automated security tools for finding very bad bugs in software. By bad, I mean like the ones where you could achieve remote code execution, for instance. So those are pretty serious. But when it comes to like fuzzing itself, you could look at it from different perspectives. You could look at like specific tools, but you could also look at it from like a broader, more abstract angle. So and it's more like abstract angle. It's about like throwing like seemingly random inputs at your program and like verifying some kind of property. So most commonly that would be like the native code fuzzing, where we would find program crashes, right? But those crashes could be like memory corruption vulnerabilities, which in turn lead to those vulnerabilities, which could be very, very bad.
Yeah, and my mind always goes right to the memory fuzzing, the very large world of C and C++ code that's out there lends itself, I think, very easily to fuzzing. But you in particular have been looking at fuzzing that's not just about memory safety, and even not even just in C and C++. And that to me is pretty interesting because, as you just mentioned now, you're looking at properties of an application. And yes, those properties could just be, is this buffer slightly large, slightly too small, off by one, whatever. But tell us a bit more about, the properties of an application. And to tease us a little bit, you've been doing work with smart contracts as well, which, again, they seem like a great target for fuzzing. Why is that?
Yeah. So a property for a native program is like, you could state it as it's free of memory corruption bugs. Like whatever input I throw at it, like it could exit in various ways, but it shouldn't corrupt the program's memory. So this is sort of like a natural technical property of program, which almost always results in bad things if violated. So we have this property, but some programs, like they don't have such intrinsic, or like some platforms, they don't have such intrinsic property. So one of those are smart contracts, as you mentioned. I'm talking specifically about Ethereum smart contracts, but this could be extended to other platforms as well. But like the particular case I'm talking here about is one of the fuzzers I was developing at TrailBits. So this fuzzer is like exercising properties of smart contracts and tries to invalidate them. And you might ask, like, what are those properties, since like the system itself doesn't have such intrinsic properties like memory safety. So here you write those properties by yourself. So this design was inspired by property-based testing. So property-based testing is sort of like upgraded like unit testing, where you don't exercise just one input and validate. Like with assert some property, you have a framework which generates many test cases, for instance, during CI runs, and it validates the same property. So we took inspiration from that, but actually moved it more towards fuzzing, where we added like coverage guidance, like mutating the inputs, etc. Things that we know from regular, or like most commonly known fuzzers for native code.
Yeah, and I definitely want to come to the coverage aspect in a moment. But you talked just now about the testing unit tests, or being slightly more sophisticated than a unit test. But it definitely brings to my mind then the question: why aren't unit tests? Why don't we call them fuzzers, or why aren't they so successful, or as successful as finding the flaws in these properties? Why don't we have just unit tests for, this contract is secure, to be a bit reductive?
Right. So unit tests are like most often just a single input, like single instance of input, while the fuzzer will generate like thousands, hundreds of thousands, or millions, billions even inputs that find a way, like try to find a way to explore your program and trigger like your like deepest branches in the program where the bugs could be hidden.
And that's got to be that's to me what seems a really difficult challenge of fuzzing, is to get deeper into the program, because unit tests sure are just, here are 5 lines of code. Did those 5 lines work? Whereas if you're and even with a memory safety, that's kind of just, here's a big blob of text. Here's a really large field. Okay, did it go over length or under the length for that matter? But especially with these smart contracts, you're trying to build up a complex state just to see what happens. How much of that is, do you direct a fuzzer, so to speak? And here I'm teasing out the idea of the corpus or that guided fuzzing, versus you've got a nice random number generator and let it create those millions and billions, and you can sit back for a couple hours, a couple days. Are both of those viable approaches? Do you have a preference in how you build up what these test cases look like?
Yeah. So the assumption is that the deeper further goes, the more bugs it can find. Obviously, some researchers argue about like how true that is, but in practice, this is usually true. So what fuzzers do is they they favor the cases which went further. So they would take those cases which explore the program deeply, they would mutate them, and they would re-execute them to see if they go even further. So so obviously the execution environment has to be instrumented so that the fuzzer knows which input like corresponds to a higher coverage than their predecessors. So this is something that is a very active area of research, like how to do it the proper way, the fastest way, etc. But in principle, like this is one of the most effective techniques, which are like coverage guided, like evolutionary or like mutational based fuzzers.
So as part of that, and especially as we start talking about performance or speed, it gets into that the other conversation of, do we do this in line with our CI/CD process? Do we just sit back and do we let the fuzzer go for a week and just spend a whole bunch of money on CPUs? What is there a particular time or even money budget that you suggest, or how do we keep that in mind to just say our fuzzing is done, or we've spent too much or too little on our fuzzing?
That's a very good question. A lot of people ask about. So each fuzzing engine will report the coverage progress it makes. So it would give you a number, so you could see if it's still growing or not, and it would also report like last time since new coverage was achieved. So ideally, you would run it until no new coverage is found for extensive period of time. That could be like a couple of hours, couple of days. There is no definitive answer to that, but obviously you'll at some point see that it's basically stuck. So this is a good time to go back and reevaluate like why it isn't making progress by like generating the regular coverage report as you would have with your unit test suite, and see which branches are not covered, what could be the reason. Then you go back and modify either the harness or some configuration, some compilation options. Maybe some code isn't executed because you didn't specify correct options, etc. So yeah.
I'd love to back up there a second. Well, at first, I think we sort of jumped in here really deep. I hope there's no one out there, one of our listeners, going like, "What are they talking about? What is a fuzzer?" But so we might want to cover that just really briefly, 30 seconds. But you hit upon something really interesting there about when you're talking about the research going into how do we, zero in on like what is the interesting areas, what sort of data should you be throwing at something. That I'd love to hear you talk about that for a few minutes, because I could just literally throw the kitchen sink at an API and just see what happens, but that could take us weeks or months. Like, what are some of the theories or ideas around how you actually narrow that down and make that a little more effective?
So what are good targets for fuzzing? So the classical targets for fuzzing are it is software which takes like concise input such as like binary data and parses it. So that'll be like image parsing libraries or compression libraries, etc. So those like this software which takes like an array of data and has to parse it and produce some structured data in memory from it. So those would be like the most classical things. But people have leveraged fuzzing in very different areas, as we talked previously about fuzzing smart contracts. So you can definitely apply it to other problems, but there is like different difficulty levels of or like expertise you need to have to do it. With those simple parsing software, you don't have to like work around usually that much around the software. In some other cases, it might be necessary to tweak the software itself. Like if you have source code, like you might need to like reorganize it a bit for the fuzzing build, or like comment out some non-critical branches which are difficult for fuzzer to penetrate but don't contribute like that much to the overall software.
Well, and maybe one of the things that caught my eye, actually, why I also wanted to reach out to you was you were fuzzing some barcode scanners, which feels both very fun and also very, images are a classic target for fuzzers, as you were kind of describing. Maybe talk us through a little bit how maybe why you chose barcodes, because that does seem very random, as well as, what did you have to do to John's point, to either set up the code to make it fuzzable, or what did it mean even to start fuzzing for listeners who are maybe not, who've never played with AFL or don't even know what I'm referring to when I shorten it to AFL.
Sure. Yeah. So I found like a popular barcode scanning software. So it's called ZBar. It implements many barcodes, including QR codes and similar things. So it's very featureful. Why I decided to fund it was used by one of our clients, and we wanted to get like a quick assess of like what's the security of it, given that we haven't found it like any public traces of it being actively fuzzed. So that's always our first thought. Like if there is like easy target for fuzzing, and there are no traces on the internet of it being fuzzed, there's probably some bugs. That's the assumption. So I didn't even like I didn't have much time for doing that, as I said. Like that was just quick assessment, but just simply following, like almost simply following a fuzzer Reddit. In case that was a fuzzer, one of most popular fuzzing engines, which comes with Clang or VM project. Like it uncovered bugs like pretty quickly without even like giving it like a proper corpus. Um, I stopped at this point as I ran out of time. I would like to like very much go back to this topic when I get like a bigger chunk of time. But you can already see that um, like taking a project which wasn't previously fuzzed or like no one like disclosed. That they're fuzzed it and didn't fix the bugs. It's probably a pretty good target, especially given that there's essentially a function which takes input as an image and parses it into the data that's contained in the barcode. So the fuzzer would generate those images. It would feed it into the ZBar library, and then it would parse it to the data.
So part of you mentioned corpus, and I've mentioned that too, and that a corpus is a key part of fuzzing. But we probably should also talk a bit more about what is a corpus, as opposed to I don't have a good joke there. Just what is a corpus? And with barcodes, it does seem pretty straightforward to say, everyone has seen a barcode. We're almost surrounded by them. But what is a good corpus for barcodes? And if you were, we're going to turn Artur into a little bit of a human fuzzer, as well as, what are you predicting, or what would a lot of the test inputs you would hope a fuzzer is generating for something as simple as this barcode scanner?
Well, yeah. So obviously that's pretty natural. That's pretty natural. Input is simply a barcode image or like a QR code image, etc. So if you have such like bunch of images, you could like pre-process them so that the fuzzer can understand them and feed them into the fuzzer. The benefit of it is that it will explore the program much faster, because it doesn't have to like figure the format out like on its own, which is possible. There was this fun blog post by the author of AFL, like pulling JPEGs out of thin air, who essentially shows in a blog post that like the fuzzer, without any input, like fuzzing the like a JPEG parsing library, will start producing JPEGs as inputs in like if you give it enough time, basically, because that's the only way of exploring the program further and further. And this is what the fuzzing engine promotes, to explore program further and further. So naturally those inputs will start to resemble valid images. They'll be very simple, but yeah, you could even have ones that you could open.
And I think it comes back to that earlier question too about how much of a unit test when you've done this fuzzing, do a lot of these does a successful fuzzing input, does that become a unit test? What happens? What does the sort of broader feedback loop look like after the fuzzer has caused a crash or caused something to panic, error out, and other string of synonyms there?
Well, that's a good question. I think it really depends on the nature of the bug. Yes, it's usually good to like first to find the root cause and fix the bug. Sometimes like finding root cause could be time consuming on its own. Like you have to run the input, you have to debug the program. If the program is sufficiently complicated, it could also take considerable amount of time. So, but yeah, ultimately you fix the bug and you could add this input or like a minimized form of it, which triggers the bug back to your unit tests. So to make sure there aren't any regressions, but just simply using your regular test suite.
So part of that too then is it takes time on the one hand just to build unit tests as we write code generally. Hopefully there are just some unit tests exist. It takes even more time to run a fuzzer. And here I want to tease out some aspects of efficiency in the sense of if we run a fuzzer, does every crash become is this a CVSS 10.0 type of finding, or is it wasting our time to run a fuzzer even when there is a crash? And again, I'm perhaps leading the witness here, but tell us more about just the benefits of fuzzing, and are they security problems or not? Or is that even an important part of the question?
I think it is an important question. So you'll get different kind of findings, different like quality of findings, and different quality of bugs, and different seriousness of the bug, right? So you could get like very very like the most critical bug you could you could imagine, but you could also get um like a bug which is technically a vulnerability, but it's not like exploitable, for instance. Or you could even get like false positive because like you wrote your harness or instrumented program in the wrong way, or you could even like hit the bug in the fuzzing engine itself, or like some other parts in the program which are not actually run in the production build. So yeah, definitely you can have very very serious bugs, and people have found like very critical bugs using fuzzing. But again, like you have to triage each crash case by case.
One of the things we've also been talking about is that because these are crashes, these are finding software bugs. These are bugs that should be fixed, and I think that's a great thing. We've also kind of been claiming, maybe we don't have to support it, but we probably should, that fuzzing, is successful and perhaps even better than some other tools. If we say, hey, we have a fuzzer, is that sufficient? Do we need a SAST, a DAST, other tools? And here I'm not getting into vendor competitions. It's more about choosing tooling and trying to be efficient, trying to save our time, spend as little money as we can on CPUs, because things get expensive, especially if we have to run something for a week or even a month. So how does a fuzzing tool fit in amongst the AppSec toolbox for you?
Well, yeah, I think like AppSec is about like leveraging as many tools as you can, which could like give you or like reassure you that your program is correct. So fuzzing is definitely in this toolbox, along with like regular testing, along with static analysis, etc. It's just a bit more manual to set up, and a bit more resource consuming than maybe the other tools. But like we always try to convince our clients, especially when we see a good fuzzing target, is like we talked like previously, like parsing code is one of those cases which is very natural target for fuzzing. We always recommend our clients to incorporate that in their like a development life cycle.
And part of that too, then, is also the aspect of, I know that code is being maintained. Is if the code is changing, it's being actively contributed to. That seems like making a good case to keep running the fuzzer. But you've mentioned before that the coverage could possibly become saturated, or you hit. I don't know if any even unit tests have always reached up to 100%. I know SQLite, for example, notably has a very impressive coverage. But what about, I guess, how do you know that you are saturated, that you have enough, that you need to be doing more?
Yeah.
Or stop, for that matter.
Well, yeah, like every fuzzing engine will show the coverage measure in one way or another. So you'll see if it stopped itself or not. So yeah, at that point, it's good to go back to the project, like rebuild it with like a regular way of instrumenting it for generating coverage reports, like you would for like measuring unit test coverage, for instance. But then you run your harness with the corpus, which essentially represents all the coverage that your fuzzing efforts gained. So this should cover like represent all of it in sort of like a compressed form. So we can then take a look at where your harness like how will your harness explore the program given like your fuzzing effort so far, and then you could see the blind spots, and some of them are quite easy to fix, and some of them maybe not so easy. But it gives you like a nice visual representation of actually like where the fuzzer went, like how deep it went. You can see it on the code, which branches were executed, etc. And often you would be surprised like how hard it is to actually have very good coverage with a fuzzer. Like there's surprising things that can happen in software that are hard for fuzzer to pass through, basically.
And especially a lot of that is if you need to set up a complex state to get into one of those code paths, that your random number generator could easily spend a long time on something that's just not going anywhere. And I know what you've been describing too is essentially a feedback loop of this is an input, this is what happened, or this is what the coverage looked like. And there's a great engineering principle just to have that guided fuzzer to say, try something else or iterate in this other manner. We haven't talked about LLMs yet, and is a sort of a maybe not too joking hypothesis that I have is that on a cycle per cycle or cents per cycle, to me it feels a smarter use of budget to spend your money on running fuzzers and burning CPUs like that versus running spending money on GPUs and having an LLM just look at code and try to guess it, whether you found a problem. But how do we get this? How does the LLM fit into the picture? Is it useful? Is it a replacement or what?
Yeah, I don't think it's a replacement. It's a very good complementary tool, or like it could be a very good complementary tool. So as I said earlier, fuzzing is a bit of an art. So it doesn't matter if you get everything 100% right or not. And this sort of meshes well together with LLMs, which are also a bit of a fuzzy tool, which isn't guaranteed to be correct. But you could we talked about corpus. There is also there is corpus, but there are also like dictionaries. Those are like pieces of data which you could tell your fuzzer to use that fuzzer will have very hard job to find out about, but you could tell them, okay, we're fuzzing like SQL parsing, for instance. So here are the SQL keywords you can use. You don't have to figure them out on your own. I'll give them to you, like use them when you generate test cases, so that you can explore the program faster. So usually, you'll have some of those dictionaries or corpuses prepared for popular software or popular protocols. But if you're fuzzing a new project or like some proprietary protocol, etc., you might want to use, for instance, LLMs to go to the source code and tell them basically, okay, gather me all the like keywords I could use for a fuzzer, and it will collect something, right? We could try, like, if it increases the coverage, if it allows fuzzer to move forward, and you won, right? If not, you can just discard that. That's one thing which you could use LLMs to improve the effectiveness of fuzzing. But there is also another thing. So when you target functionalities inside programs, you would write harnesses which target like a specific function, but that rarely covers the whole program. But there might be some other targets which inside the same program, which are also interesting to be fuzzed, but no one bothered to write those cases. But collectively, they would altogether cover more of this of the entirety of the program. So so you could see that in various software where like the most popular function is fuzzed, or like the most used, but there are many others which could be also fuzzed by simply like tweaking or adjusting the original fuzzing harness. So you could also leverage LLMs here to like generate code which would exercise those different parts of the code base, and this is what the Google team is doing with OS's FastGen project. I think this is still sort of like exploratory work, but it's fascinating to keep an eye on it.
Yeah, and it seems like a wonderful way to invest into the open source community, OSS Fuzz, that you mentioned, in the sense of also just improving software quality. And it goes back to that idea that the fuzzer found a crash, perhaps it's exploitable, but in any case, it's something that is code that can be improved. And as we're starting to, I've been speaking about time a lot, as we're starting to come to the limits of our own time budget, one of the things you were just talking about now is, tweaking the inputs, LLMs being helpful for guiding, creating that dictionary or understanding how to interact more effectively with the program. I'm always reticent to make any suggestions to developers in the sense of make your program easier for a security tool. Meaning our first goal should just be easier for humans, easier to understand, better for the architecture, not just so a SAST or a DAST or a fuzzer, for that matter, can use it. But with that said, we have been talking about like unit tests or even functional tests. Are there ways to approach just the testing, the normal testing patterns of an application that can also just be more conducive to fuzzing? Or maybe what I'm trying to get at, what's a good way to be successful at fuzzing, or what's something to avoid, or just to say, this target is just not going to be conducive. It's too hard for whatever reason.
Well, yeah, I would have to think about like what exactly you could do, but I think first of all, like having like a clear and well-designed test suite is already a big win, because if someone is not familiar with the product but has expertise in fuzzing, one of the first places they would look at is the test suite, because you can get a feel like what are the inputs to the program or like to various functions. If those inputs are specified in a clear way with some documentation, there are some test vectors. You could already take a lot of interesting properties from this area and make it more automated with fuzzing. So that will naturally extend your regular unit test suite. It's sort of like like we went the other way previously with taking a crushing case and encoding it as a unit test so it doesn't regress. So here we would go the other way and draw the expertise from the test suite. And also, if you use if you build native code, it's always a good practice to run your test suite with sanitizers like address sanitizer, which will surface bugs. And this is also this instrumentation is one of the most essential things when running fuzzers. So if your product already built with address sanitizer, then it's way easier to set up a fuzzer, which almost strictly requires it. Maybe not strictly, but yeah, it's almost always a requirement.
I think, John, did you have one more question that you wanted to?
I did. I know we're running out of time.
Yeah.
That's why I was keeping my mouth shut.
Let's go for it.
Oh, there goes my camera. I'm going to ask the question anyways. Thinking back on the LLM stuff, we were talking about using an LLM to help with the fuzzing, but what would your thoughts be around using an LLM to fix the results from the fuzzer? In other words, I don't know if you have any experience with, going out to Claude and saying, hey, we fuzzed this application, we found this problem, help me fix it?
Good question. I don't have any expertise with that, but I would like to someone evaluate that. So yeah, definitely a good question. But I would imagine it's pretty hard problem.
Yeah, and that's interesting. So, and I think the theme of that aspect really is where are LLMs helpful in either expanding our test cases, understanding our test suite, even understanding the code. But I wasn't even thinking about the fixing side. So I guess we will have a world of spending lots of time on CPUs for what have you. But Artur, we're talking about dictionaries, and large dictionaries tend to be better because we have lots of words to throw into a fuzzer. But we have a very restricted dictionary that we ask our guests to answer. This is AppSec in 3 words. How would you respond to this particular prompt?
Yeah, I think AppSec is just identifying software shortcomings.
That's pretty succinct. And I guess as we've been talking about fuzzers, the more you can do that through automation, this feels like the better. So we can spend our time playing D&D or something else. Who knows? But Artur, this was a fun conversation, and we're going to find out what you've been fuzzing over the next year or two, and have to have you back. Do you have something in mind of a new target or something that you really want to go fuzz?
Yeah, I'll definitely want to go back to the barcode scanning. There are also different libraries for that. So that would be interesting research, but I'll need to have a bigger chunk of time to to work on it.
Well, we'll wish you plenty of time to do that, and we'll keep an eye out for some new blog posts because that's always fun. I want to say thank you once again, Artur. Thank you to John, and thank you everyone who's been listening. We're going to take a quick break and return with news of the week. Welcome back to Application Security Weekly. We just talked with Artur Cygan about fuzzing barcodes, why fuzzing is fun, and how fuzzing fits in with software testing. I'm your host, Mike Shima, and I'm here with John Kinsella, who I don't think you're fuzzy about the news and many of the principles we try to cover, but I tend to be a bit fuzzy when I try to explain them. So let's see how at least I take that challenge this week as we dive into some articles that I was trying to pull out at least, on a theme of secure design, secure defaults. So trying to be less specific about the actual mechanics of an exploit or a vulnerability and more about what could we learn from it. So that's my fuzzy introduction to poor John, who has to sit here and listen as well as all the listeners. So John, bear with me. I'm going to look in the mirror. This is from the Red Team Pen Testing blog, a look in the mirror, the reflective Kerberos relay attack. And what's kind of neat about this, it sort of shows that what's old is new again, especially with some really effective and really neat research just to say, hey, Windows has had a NTLM, replay attack for over a decade. It gets patched, it seems to get fixed, but maybe it's not as fixed as we thought it was. And it's a great technical write-up. It also calls out to some great work from Google Project Zero. Shout out to James Forshaw over there, his work on these types of replay attacks. It definitely gets into some neat technical details. But for me, what stood out and what I thought might be interesting, so let's test my fuzzy thinking here, John, is why and how this happened in the sense of, as they explain, there's probably a good decade of Windows systems that are vulnerable to this, but there's a subset that in the last half of 2023, the last half of 2022, that the default settings of these Windows systems actually makes the exploitations difficult. And part of this is about what's called the coercion aspect of it, and also enabling SMB signing by default. And that SMB signing is a pretty strong way to tamp down any type of replay or spoofing or tampering if we want to give a call back to our Stride threat modeling of last week. So it brings to my mind one of those questions of, well, how come we just didn't have SMB signing from the beginning? Because that could have potentially solved all kinds of headaches for us. So I don't know. On behalf of Microsoft, John, maybe you can answer this rhetorical question. So,
yeah. To answer the last part first, we could have had SMB signing from the beginning, but there might have been a bug in that, right? So it would have been closer, but there's no guarantee, unfortunately. The first thing that caught my eye in this article is when they start mentioning Kerbos. I'm like, oh, this isn't a flaw in Kerb in general, is it? No, it's specifically with how they were doing it. I mean, I'm sure this isn't the first, but it's a very solid example of what happens when you start changing those defaults and adding some of these signing and things that we talk about. So personally, I think that's really great. And I'm not sure how much more there is to say there. That they've got an interesting little POC in there of like actually, doing this, which is always impressive to see compared to just like talk about something. So I'm glad they put that in there. But it's I don't know. What's the last time you touched a Windows system? I know there's a ton of them out there. I'm sure some of my team uses Windows, maybe one or two, but it's pretty rare. At least in my mind, it's a fairly rare thing. So it's if you're a pen tester and you're doing a Windows site, it's probably Christmas Day, but for the rest of us.
Yeah, once you see Active Directory, it's sort of like, let's start the countdown until we have domain admin. But it is another reason I grabbed this blog post. There's a little bit of a callback to our discussion with Artur previously about fuzzing, because to set up this particular replay attack, as the blog describes, it's actually creating a ticket that's saying that, hey, this ticket, dear AD, dear server, that you just received is actually coming from localhost. So this is why you should be responding to it, but you're responding to me as the attacker who's not on localhost, or the request hasn't come through a local request or a local interface. And it's also saying, and by the way, I'm asking for this authentication, and I only support Kerberos. I don't support NTLM, and that's part of the nuance of how to get this exploit to work. So there is definitely some setting up some state, if you will, to get this to work, and that's a callback to the complexity of getting, exercising those code paths with the fuzzer. Another reason this came to mind is, I mentioned signing. There was last year the golden ticket attack. Even with signing can go a bit sideways because you have parsers who are like, oh, this looks like XML. But you made a mistake here, but I'll just pay attention to this other area of the XML where you didn't make a mistake. And oh, look, there's a valid signature for this. It just happens to be a valid signature that has nothing to do with the payload that's contained herein. And the reason I'm introducing it that way is that we've got a blog post from Trail of Bits. Shout out to them. We like to cover them almost every week, it seems. But this is the Unexpected Security Footguns in Go's Parser by Vasco Franco, so one of Artur's colleagues. And this is a really neat blog post where he goes through parsers for JSON, XML, and YAML, and showing how the unexpected behaviors specific in Go, or perhaps we should say unexpected or different behaviors from other parsers not in Go, handle these different types of formats. And before we get even further, John, if I say, you have to deal with a configuration file and you have to write them in JSON, XML, or YAML, as a human, which one are you going for?
JSON.
JSON. Oh, wow. Because I'm going for YAML. I just like JSON has too many quotes and too many nesting in curly braces that I get lost in personally.
For me, I like that level of structure. Yeah. Whereas YAML, very frequently, I use it just enough that I spend too much time trying to figure out, is this a dictionary or a list? And
fair.
Come on now. The language, I guess it is language. The format is a little, I wish I had a little more structure. That's just my own personal opinion.
And what's interesting there too is that, and part of the reason I was asking is that one of there's two perhaps themes to this blog post. One is that different parsers behave differently, and when that happens, you get into vulnerabilities. The other aspect is that even with JSON, for example, is one of the formats that he picks on, humans make a lot of mistakes too. And one of the really neat examples is just with JSON serialization, you can omit fields. And part of the blog post is describing that in their experience, they're looking at serialization of authentication APIs, for example, and what's the username and password that's coming back and forth, or is this a person, is admin, which is a very simple just way of showing what's their privilege level that's being expressed as part of this JSON blob. And typically you would omit an is admin because you don't want that to come to the client and then be returned from the client in a way that is not signed or doesn't have any tamper resistance around it. So a user could just very trivially update themselves or upgrade their privilege. And one of the ways to omit a field is just having a dash or omit empty. But what's really funny, maybe sad, we need a better word for this, is that even within the JSON spec, you can say if the field tag name is dash, that will be omitted by the parser. However, a field name can still start with a dash and will be accepted just as a field name. So already that's like there's an easy oops there. We can see what's going to happen. As well as you could have a field name that's in uppercase or in mixed case, but if it's doing case insensitive matching, suddenly you can have 3 different fields with 3 different values being interpreted in multiple ways depending on what parser you have. So I don't know. The reason I wanted to grab this, John, was to talk a little bit more about just building software and making those decisions. If we were to create the ASW, the new text file format for humans that's machine readable, and we have multiple fields, redundant fields, duplicate fields, as I'm repeating myself, how do we handle them? Is it security? Are we friendlier to mistakes for developers might make? What happens here?
We just give them to ChatGPT and have it parse it for us. Come on, it's easy. I hear it. The Go examples bring back my fond days of Go. My answer to that, honestly, is just use a static analyzer, right? It should be able to catch these and point those type of things out to you. Maybe not all of them will, but we now notice a problem, so that's good. Now, if you notice something, what are you going to do about it? Are you going to go through each struct and try and figure out, am I doing the right thing or not, or sort of blah, blah? Or do you just have some sort of a tool which goes, hey, do you want this to be exposed or not exposed, and go from there? That would be my preference. Code reviews are great, but we're all different every minute of the day, so that's sort of the problem there with the humans. I like the example that they have in here about halfway down. They refer to a CBE 2020-16250, when there was a auth bypass in HashiCorp Vault when it was being used in a conjunction with AWS. And it was sort of interesting that the actual issue there was they managed to figure out you could say accept JSON in your header that you pass into the initial request. The response would come back to the Vault as JSON, even though the Vault could only handle XML parsing. But the XML parser is so sort of like, I'll say casual, that it would accept something that had curly braces and looked like it might be XML, and next thing you know, it's parsing something that's not anything, and you just kind of auth bypass. That's sort of the problem. The next thing we didn't mention, you only gave me 3 options. What happens if we talk about TOML or some of the other ones out there? Like, what,
Well, and maybe, we'll have to do another. There's a lot of vibe parsing here because you kindly described the XML parser as being casual, let's say, but that obviously is heading to problems. And if we were writing our own parser here, just at what point do you even have a decision point about how strict you want to be versus you'll be a little bit forgiving, let's say, some vibe forgiveness of some mistakes?
We'll play with this for a second. So I guess the first question would be like, what are we writing a parser for? If we can, or what's the use case, not what's it for? So like, hey, it even could be YAML, but if we can say, we're using a subset of YAML or JSON or any of these type of things. Like we've got a very specific reason we're creating a parser. We don't want to use something off the shelf. Hopefully it's not just an experiment. So we're either memory constrained or there's some sort of special field we want or something. So, okay, now we know what we got. Like there's a certain number of fields we're expecting. So it's a specific thing. So at that point, it's going to be easier for us to do input validation on and actually check what's going on and those type of things. And I think if that's done right, we've got a pretty good chance of being successful. If you go to write a general parser that's going to be the next great thing that can be used by anybody, that's when you start getting onto an episode of ASW, and we talk about you in a few years when you've got another vulnerability.
And to build on that example, if I'm writing the YAML or the TOML or I think JSON as well, front matter for a blog post, like the Hugo static site generator, it supports a whole bunch of different of these parsers that you can set up. The front matter for a blog post, we could maybe be more forgiving. A mistake there is going to be like, oh, this was a misspelling, or a field's going to be omitted, or it was that array and not a dict, or backwards, what have you. On the other hand, if we're talking about Kerberos authentication and XML, you want that to be more strict. You want that to error quickly and fail on errors. Same thing here in the write-up that they were showing for that HashiCorp Vault vulnerability. Mm-hmm. You don't even want that ambiguity between JSON but suddenly XML and vice versa. That's a weird confusion. And it gets into those ideas too about one of the other themes of this blog post was pointing out that there's a lot of behaviors like if you have duplicated fields, do you take the first one? Do you take the last one? Should you error? And typically, most of the parsers just take the last one, and that behavior can't be changed. So you can't even say, well, I know that there's a discrepancy between these, but you have to live with it unless you actually want to go in and change stuff. It does point out that JSON v2 parsing is going to be more strict and actually has a lot less ambiguity. But who knows how long it's going to take for people to adopt that. If we were just talking about a vulnerability in Windows, with NTLM replay or Kerberos replay and tickets, been around for decades and has been very difficult and slow for Microsoft to get that secure default to protect against it everywhere. So I think that's more of maybe my rhetorical interpretations of this article and kind of what it means about building software and making decisions, because it's where these making decisions is where I think AppSec becomes a more interesting conversation. So John, what kind of decision do you have here if we're building on that error handling as well? Do you take the first, do you take the last, or is this where your linter is basically failing the build or going to fail secure or fail closed for another term here?
I can't remember the specific use case. So where I want to go is something a little bit different, and you have to have the right data types on the target side. But I'd much rather take all the values, give them to me in a dictionary and array, and then let me pick. I can't remember. I haven't gone through that case before. I can't remember if it does it for as long as there's an array on the inside, or it might be a particular parser that does that. But that's sort of ideal for me. Maybe someone was stupid, and we want to be able to identify that. Maybe not. Pick your words. Yes, they were stupid. Obviously, if they have two values in the YAML file, you're dumb. I'm going to commit. If maybe they have if they have that in there, you want to actually be able to put an error out and say hey, there's two of these. Is that what you wanted? Or maybe there's some other way of that makes a little more sense. So, but yeah, I'd like to have a little more access to those multiple if they're there.
And part of the reason I was asking you, John, is that I feel like we could set up a top 10 list, if you will, of all the parsing mistakes that could ever be made. And this could be the ASW top 10 parsing list. And we could get onto Simon's top 10 OWASP top 10s. So this is a fun, a bit jokey Git repo where a good friend from ZAP, Z-Attack Proxy, has thrown together a list of top 10 lists. And there's, of course, the OG one, the original web top 10. There's API security top 10 for LLM apps. And then it gets into others that tend to be redundant, honestly, with either the original OWASP top 10 or maybe API security with it serverless mobile that pretty much boil down to different interpretations of you had broken authorization or broken access controls and you should have done more input validation. But yeah.
He's actually got on here both, he has both the top 10 for LLM apps as well as a machine learning security top 10. I know they're slightly different things, but, and what I was looking at was, so these are, for folks curious about this, how he sort of ranked them. They're sorted by a number of GitHub stars. So it matters when you go and start those projects out there for sometimes. But what was catching my attention was the last commit. So for serverless top 10, the last commit was July 2020. And there's a few that are 2023, some 2024, but a top 10 not being updated in 5 years, is that abandoned, or is that it's sort of a set space? Maybe, I don't know. I'm not sure what I think about that one.
Yeah, and I think for me, because people know I love to make fun of the amount of top 10 lists out there, but you're pointing out the curation of them. They should change over time as we learn better defaults, better design choices. And for me, just to see the web top 10 and the API top 10, that feels like a significant area of overlap, a bit even more overlap than the LLM versus machine learning. Because yes, those are clearly, or maybe not so clearly, but they have different fundamental designs between an LLM and ML. But if we look at mobile top 10, yeah, there starts to be some difference from API security, but there's all this overlap in there. So maybe this was just a way to, yes, let's get some parsing top 10 in there. That will be my goal for the end of the year. I'll write my own top 10 list. And that way the last commit will at least be December 31st, 2025. So that's my pledge to you, John.
That will make me happy.
Always looking forward to making you happy. I've had another article in here from Qualys that they've got a researcher in there who just loves POSIX and Unix systems, loves to dive into details. It's kind of not quite obscure, but it's definitely a very narrow focused type of vulnerability that is not necessarily relevant to everyone, but it was a flaw in PAM and the lib block dev, or the udisks feature within Linux. But the thing that stood out to me really is that, as it describes, PAM and defining policies in there can start to get a little bit complex. And when you start to do that complexity, you potentially as humans lose a little bit of understanding of, oops, I didn't realize that this particular service or this particular combination of service and policies actually had more privileges than I expected. And that's very much a reasoning. It's a complexity aspect. It's not quite so much parsing, even though we're talking about parsing files. But I thought that was just thematically, I wanted to pull that out, even if this udisks wasn't really a bit of a shrug for everyone else who probably doesn't have that. But in the spirit of trying to make you happy, John, I wanted to give you the last word for the week here. How can we send off our listeners with some good ASW
I think what's fun about this one is I'd love to know the backstory and how he found this, how they found this. I have no idea who it is. Did they install OpenSUSE 15 and started screwing around with it and like, hey, let's go change our OS distro we're using? Or were they always using this and tried to like mount something and had an idea? Or like, it'd be interesting to hear like, how did they get into a situation of going, hey, we can actually chain these few things together? The other thought, you're mentioning parsing and PAM. How many PAM vulns have we had over the years due to parsing, basically? Maybe not all of them, but a good number of them are. So that's sort of I think probably a poster child to wrap up with a security library that has parsing issues.
There we go. Rewrite it in Rust. That's what John just said. I'm putting words in your mouth now. As I said, I was going to make you happy. So apologies in advance. But thank you right now for John for joining us and taking the time to suffer through my fuzzy brain as we talked about all things fuzzy and parsing. Thank you everyone as well for joining us. Please do remember to subscribe. Check out the show notes. We have some links to a lot of the segment with Artur, some GitHub repos about some work that he did there. And please do share us on the socials. And speaking of big things, check out Goliath by LeBrock. We'll see you next time on Application Security Weekly.